Hi sailors, my name is Shishpal and welcome to my channel Maths Pirates. Hope your day is being good and your learning journey is being awesome. Now let's deep dive. Let's start the aspect of our video deeping deep dive into the world of mathematics, sailing the seas of knowledge. So sailors, our today's aspect of this video is about relations, right? The world with invisible relations. Okay, in previous video I have explained you about the aspect of abstraction and the four levels of mathematical abstraction, right? See, regarding abstraction, another thing I want to add, as I mentioned, that abstraction is hiding the unnecessary details and showing what is necessary, with like what is required for us to use that thing. The information that is being known for awareness but not much in use, right? Those things are hidden, and the things, the aspects that are necessary to be known so that we can, which are being repeatedly used, which is called as abstraction, right? Regarding abstraction, another example, see, if you are a CS student, you are well aware of the aspect of programming, right? Of different programming languages, C, C++, Java, and prominently Python. If you are a web designer, you are aware of HTML, CSS, JavaScript, right? Now, the best example, let's consider Python. See, in Python, when we compare the lower level languages, right? In lower level languages, we need to define everything. We need to create a function for every activity. We need to write an algorithm with certain steps, certain instructions in a proper structure, so that the program, when it get executed accordingly, will get our desired output, right? But in the middle level languages, we have some inbuilt functions. Suppose in C program, it's a middle level programming language. In C programming, we have the fundamental function that we learn in the beginning is printf, right? See, suppose you are reading any reference book, right? Which is technically, which is huge with technical words. So in order to understand that book, you will be having an Oxford dictionary beside you, right? If you don't understand any line or any word, you just refer that word in the dictionary and you know its meaning, then you understand what the references book trying to teach you, right? Similarly, in C programming, suppose we are using printf, but because it's a built-in inbuilt function, which means the printf function is already defined, we can just directly use it, right? The only thing as a programmer we need to know is how the function is used, where it is used, what's the purpose it fulfills, right? The inbuilt functionality, the inbuilt code is hidden from us, and that inbuilt code is written in header files. That's why whenever we write any C programming, we begin with hash include studio.h, standard input output.h, right? Similarly, when we go to higher level programming languages, especially Python, you will be having huge many built-in functions, right? Extreme level of abstraction. See, you need not know how those functions were built in, but only you need to know is how to use them. How those inbuilt functionalities makes our code simple, right? This is another best example of abstraction. When you come to when you learn Java, it's a separate aspect abstraction along with inheritance. Even in C++, you come across the aspect of inheritance, right? See, this is a small thing I wanted to share with you regarding abstraction. Coming to this video, let's begin with the aspect of relations. See, in previous discuss video, I explained you about comparison, right? As comparison as a relative term. Whenever I consider this pen, and if I want to say whether the length of this pen is big or small, whether the length of this pen is big or small, we can't say that, because if it is need to be big, there must be any other pen that is smaller than this one, right? If that this pen is considered to be small, then there must be other pen which is large in length compared to this pen, right? So I say, as I mentioned, comparison is a relative term, right? There is nothing like absolute identity for individual objects, right? An identity, the characteristic identity of an object is always a relative term, right? Suppose, how another example, how can we say that a person is farther away from us or near to us, right? Because the position where we are standing, we consider it as a reference. We consider it as a reference to measure whether the opposite person is far away from us or near to us. Two persons are standing across me, so that within the position that I stood, I can say that whether the person is far away or near to me, right? So that's how the characteristic identity of an aspect or an object is always a relative term. Let's Whenever it comes to science, especially in physics, you come across chapter like units and dimensions, where you will be learning uh, units as two types: fundamental physical quantity, built-in physical quantity. The fundamental physical quantities are are considered to be as absolute units of measure, right? For example, meters, centimeters, even meters can be converted into centimeters, right? 1 meter has 100 centimeters. So comparatively, meter to centimeter, the centimeter is considered as absolute, right? Whenever we compare, when we find to measure the length of any object, any one dimensional object, it is always relative to some other dimension, right? That's why in units and dimensions in physics, as a fundamental chapter to step in, you will learn that unit transformations, right? From kilometers, when it comes to weight, you come across tons. When it comes to time, you come across decades and centuries, right? See, the measurement is always a relative term. You always measure the length of an object relative to other object. It does not exist like an absolute characteristic value to an object, it is always a relative term. Suppose let's consider this pen, and I have another pen which is of this much length, right? So if I take such two pens, suppose let's consider this pen A, and I have another one pen B, pen B, pen B. The length of the combination of two B pens is nothing but this pen, right? So relative to the pen B, I can say that the length of pen A is two times pen B, right? Which is, if I name this pen as A and other this pen as B, then A length of A is equals to 2B, right? That's what I want to say. I want to say to you guys that absolute measure, absolute characteristic identity of an object or any aspect is always a relative term. Every measure, every analysis is built on relations to the previous data, right? And coming to sizes, right? Size and or color. Suppose it is, whenever I compare these two objects, this object is comparatively thick and green as compared to this object, it is thin and black, right? So specifically speaking of size, it is thick and this is thin with respect to each other. With respect to this chalk holder, this is thin, and with respect to this pen, this is thick, right? In this way, every characteristic identity of an object is always relative to other object. So the characteristic value of any measure or any quantity is built upon the the relations, is all the value, its value is always relative to other quantity. See, two measuring quantities, 1 meter and centimeter. If 1 centimeter is repeated 100 times, then it is considered as 1 meter, right? Suppose I take year, an year and a century. If such 1 year repeated 100 times, then it is called as 1 century. As relative to century and year is the absolute measure of time. E- Now consider year and months. 1 month, when that 1 month is repeated 12 times, 1 month, other 1 month, similarly 12 times, it is considered as 1 year. See, compared to year and month is the absolute measure, right? See, if I don't want to consider month, the year as the aspect of year has no meaning at all. The measure of any physical quantity, I'm repeating guys, measure of any physical quantity is always relative to each other. This is all about the aspect of relations. See, by how the aspect of relations is useful in the modern math. See, because when it comes to relation, you you say that suppose in sets. So I have two sets. You might have heard of membership operator. Like if I take an element, right? I consider a set and a set of elements. If a particular element, if that element belongs to this set, it is a type of relation. We write that that element belongs to this set. Suppose a set consists of four numbers 1, 2, 3, 4. Now I have a number 2. Now we see the 2 number present in that set. So we say the 2 belongs to that set, right? According whether then that quantity belongs to the given group or not, few characteristics are being decided. You will understand in detail of everything that I am saying when we are being leveled up in an order, in a clear cut path. Whatever the things I am teaching you, everything is in a clear cut order. So I personally suggest you to have patience to listen, to understand what I am saying, with the, even if it is already known to you, because everything is interconnected, right? Hope you enjoy this video. Let's meet in the next video with other new aspect. Until then, bye bye.